Fermat's Last Theorem, and G.H. Hardy, Mathematician, SNOB, and Mathematical Damnation. My motto: plain honesty, simple truth, easy understanding. The joy of finding things out for yourself. Did you know that as of the 28th of December 1928, all of those living and all of those yet to be born were cursed with mathematical damnation from birth? Except, of course, those of us fortunate enough to have been given salvation by virtue of having received mathematical instruction at the hands of the high priests of number theory, alias the mathmagicians. It was on that day that Godfrey Harold Hardy, of Ramanujan fame, gave a lecture before a joint session of the American Mathematical Society and the American Association for the Advancement of Science. The paper can be downloaded from Project Euclid. His talk commenced with the fairy series, which he deems to belittle those of his peers not well versed in number theory, by saying, "The theory of numbers has always occupied a peculiar position among the purely mathematical sciences. It has the reputation of great difficulty and mystery amongst many who should be competent to judge. I suppose that there is no mathematical theory of which so many well-qualified mathematicians are so much afraid." He then damns us all with the statements, "At the same time, it is unique among mathematical theories in its appeal to the uninstructed imagination and in its fascination for the amateur. And the excursions of amateur mathematicians into mathematics do not usually produce interesting results. I wish to draw your attention for a moment to one very singular exception." He then says, "Mr. John Ferry Sr., who lived in the Napoleonic era, has a notice of 20 lines in the Dictionary of National Biography, where he is described as a geologist. With a footnote, he received as a boy a good mathematical training." He then goes on to say, "He was at one time agent to the Duke of Bedford, but afterwards came to London, where he acquired an extensive practice as a consulting surveyor, which led him to travel much about the country and collect rocks and minerals. His principal work was a geological survey of Derbyshire, undertaken for the Board of Agriculture, but he also wrote papers in the Philosophical Magazine on geology and on many other subjects." He then demeans him by saying, "As a geologist, Ferry is apparently forgotten. If that were all there were to say about him, I doubt that he would find his way into the Dictionary of National Biography today." And yet again he demeans him when he says, "Just once in his life Mr. Ferry rose above mediocrity and made an original observation. He did not understand very well what he was doing, and he was too weak a mathematician to prove the quite simple theorem he had discovered." I will finish my précis of the opening of the lecture with another footnote. It should be added that Ferry's discovery had been anticipated 14 years before by C. Harros. See Dixon's History, Volume 1, page 156. Cauchy happened to see Ferry's note and attributed the theorem to him, and everyone else has followed Cauchy's example. And also with Stigler's law of eponymy. Make of it what you will, and a complete reading of Hardy's paper I leave to you. So for the benefit of G.H. Hardy, I present a simple proof of Fermat's last theorem, which he, for all his airs and graces, failed to address. 1. Take three integers, z greater than y greater than x. 2. Form the Fermat equation, z to the n equals y to the n plus x to the n for n greater than 2 and integer. 3. Multiply through the Fermat equation by the product zyx all to the power n to give the stated equation. 4. Let k1 equals yx to the power n. k2 equals zx all to the power n. k3 equals zy all to the power n, where k1 less than k2 less than k3. And let z equals z to the n, y equals y to the n, x equals x to the n. 5. Then k1 z squared equals k2 y squared plus k3 x squared. A contradiction, because it contravenes the distributive law of multiplication for the powers, QED.